Since the dawn of humanity, we have looked out towards the stars as if compelled by an unknown force, telling us, you are not alone.
Do UFOs exist? This is the central question raised in this program. Many sightings may be attributed to what are natural phenomena or experimental aircraft, amongst other things. By the end of this program, we hope to have shown you undeniable evidence that UFOs exist and that they are controlled by an outside intelligence.
Kepler believed in the law of equal equation, whereby all scientific experience could be solved by the use of mathematics. The real world is the mathematical harmony discoverable in all things. He also had visions involving space travel, and this already at the beginning of the 17th century. In a letter to Galilei, he wrote, "Let us create vessels and sails adjusted to the heavenly ether, and there will be plenty of people unafraid of the empty wastes. In the meantime, we shall prepare for the brave sky travelers maps of the celestial bodies. I shall do it for the moon, you, Galilei, for Jupiter." Isaac Newton spent many years studying alchemical research, cosmic intelligences, and the soul of the world. His law of universal gravitation involves a holistic vision. Every particle of matter attracts every other particle. Everything is interconnected, but in Newton's opinion, such a force could not arise from the particles themselves. They had no such attractive power. Rather, said Newton, gravitational force depends on the being of God. It is an expression of his will. This aspect of Newton's thought was soon forgotten, however. The hidden forces permeating the space of the universe were soon attributed to matter itself. They arose from material reality rather than from God. And when God was finally dissolved completely away from Newton's vision, what was left was a world machine in absolute mathematical space and time, containing inanimate forces and matter, and entirely governed by eternal mathematical laws. Like Kepler, Albert Einstein was strongly imbued with a sense of the mathematical rationality of the universe. For 10,000 years, man has tried to equate with the enormity of the cosmos. The concept of an evolutionary universe, which started with gods from the stars, spaceships and telescopes, will carry us into a totally changed life.
If we consider that most of the stars in the Milky Way are twice as old than our sun, 10,000 million years old, then obviously there may be highly advanced old civilizations which have developed interstellar travel. So my answer would be it is more than likely, not only possibly, but more than likely, that extraterrestrial visitors are traveling to other solar systems, other planetary systems. Thus, we really should expect extraterrestrial visitors in our solar system observing human civilization.
Tesla's advanced knowledge of the laws of electricity and magnetism, combined with his ability to put them into practice, gave him foresight into the next generation of electronics with regard to light and its structure.
He was a magnificent genius, and had he been funded to continue his work, the world would have been 100 years further in science than it is today. Here, some 80 years later, so to speak, after the collapse of his magnifying transmitter in Here we are trying to rediscover what Nikola Tesla was doing right at the turn of the century. And so we're almost a century behind where we should be. That's the importance of Nikola Tesla.
Science, in harmony with the laws of nature for the good of mankind, will hold great values in many fields and would advance its course beyond our present comprehension. John Hutchison has been working in the areas of electromagnetic forces and the changes in the molecular structure of materials for many years. He has in this time achieved a breakthrough in anti-gravity knowledge, providing spectacular examples of heavy objects flying through the air without any visible signs of propulsion. He has also made amazing discoveries concerning the alteration of compositions of materials by subjecting them to a form of electromagnetic bombardment.
We're looking at something which you know shouldn't be happening.
The result of these experiments showed in graphic detail metal heating to a near liquid state without heat. Hard metals would turn into soft rubbery objects, proving that any substance could change its form if the science involved was understood. Bob Lazar, a physicist, worked on special projects within this complex and felt compelled to reveal what he saw.
I'm a physicist. I have degrees in physics and electronics technology. I've worked in a number of scientific programs, some of which require top secret and above top secret security clearances, of which the most easily verifiable is my early 1980s job here at the Los Alamos Mason Physics Facility in Los Alamos, New Mexico. At the beginning of this first section, I'm going to give you 3 short science lessons, and once you've learned them, you'll not only know more about interstellar travel than almost anyone else in the world, but you'll know the actual method another civilization is used to travel from another star system to the planet Earth. Now, during the course of this, I'm going to have to relate information that I've learned at S4 to information that we're already aware of. And when I say we, I mean the general mainstream scientific community. So as not to waste too much time explaining established scientific facts and theories, when I say we know this or we know that, please feel free to consult any qualified scientist, professor, or science teacher to have them explain my statements to you. One of the most predominantly asked questions is, how is it possible to cross vast expanses of space without exceeding the speed of light? Or how can you travel in reasonable time and economy between points that are light years apart? Now keep in mind that the speed of light is 186,000 miles a second, which translates into roughly 669 million miles an hour. And a light year is the distance traveled in 1 year at the speed of light. Proxima Centauri, which is the star system nearest ours, would take 4 years to reach traveling at the speed of light. So up until now, when we've examined the requirements to travel these distances, we've always had to consider the problems of traveling at a speed near the speed of light. This poses problems with propulsion, navigation, fuel capacities, and even when you consider the effects of acceleration on space-time, which include time dilation, mass increase, length contraction, and a whole host of other things, it quickly becomes evident that this type of travel would require a level of technology that man has not yet achieved. The truth of the matter is that traveling these distances does require a level of technology that man has not yet achieved. But it has nothing to do with flying in a linear mode near the speed of light. We know that the shortest distance between 2 points is a straight line, so in our universe we've always assumed that the fastest way from point A to B was to travel in a straight line at the speed of light. Well, the fact is that when you're dealing with space-time and you enjoy the capability of generating an intense gravitational field, the fastest way from point A to B is to distort or warp or bend the space-time between point A and B, bringing point A and B closer together. The more intense the gravitational field, the greater the distortion of space-time and the shorter the distance between points A and B. Referring to the graphic here, the solid line denotes the position of a star that's located behind the sun, and the dotted line shows its position as viewed from Earth. This is made possible because the sun's gravitational field distorts the space-time and light around the sun, allowing us to view stars which should be hidden from view. If we refer back to our original illustration of space-time distortion, we can see that when we generate an intense gravitational field, we can distort the space-time and in turn the distance between the point where we are and the point where we want to be. We can then position ourselves at the point where we want to be and then stop generating the gravitational field, allowing space-time to return to its natural form. In this manner, we can travel great distances with little linear movement, and this is how space-time distortion translates into reduced distance. Now back to our original question, how is it possible to cross the vast expanses of space required for interstellar travel without exceeding the speed of light? This is accomplished by generating an intense gravitational field, distorting space-time and allowing you to cross many light years of space in little or no time and without traveling in a linear mode near the speed of light. The next question is, how do you generate a gravitational field? Up until this point in time, I've used the term generate to describe the capability of producing a gravitational field, but since I'm not aware of any way of creating a gravitational field from nothing, a more accurate term might be to access and amplify a gravitational field. And this is what I mean when I use the term generate. To understand how gravity is generated or accessed and amplified, you must first know what gravity is. There are two main theories: the wave theory, which states that gravity is a wave, and the currently accepted theory of gravitons, which are alleged subatomic particles that perform as gravity, which is total nonsense. Well, gravity is a wave, and there are two specific different types of gravity: gravity A and gravity B. Gravity A works on a small or micro scale, while gravity B works on a large or macro scale. We are familiar with gravity B. It is the big gravity wave that holds the Earth as well as the rest of the planets in orbit around the Sun, and holds the Moon as well as man-made satellites in orbit around the Earth. We are not familiar with gravity A. It is the small gravity wave, which is the major contributory force that holds together the mass that makes up all protons and neutrons. Gravity A is what is currently being labeled as the strong nuclear force in mainstream physics, and gravity A is the wave that you need to access and amplify to enable you to cause space-time distortion for interstellar travel. To keep them straight, just remember that gravity A works on an atomic scale, and gravity B is the big gravity wave that works on a stellar or planetary level. However, don't mistake the size of these waves for their strength, because gravity A is a much stronger force than gravity B. You can momentarily break the gravity B field of the Earth simply by jumping in the air. So this is not an intense gravitational field. Locating gravity A is no problem because it is found in the nucleus of every atom of all matter here on Earth, and all matter anywhere else in our universe. However, accessing gravity A with the naturally occurring elements found on Earth is a big problem. Actually, I'm not aware of any way of accessing the gravity A wave using any Earth elements, whether naturally occurring or synthesized, and here's why. We've already learned that gravity A is the major force that holds together the mass that makes up protons and neutrons. This means the gravity A wave we are trying to access is virtually inaccessible, as it is located within matter, or at least within the matter that we have here on Earth. However, the Earth is not representative of all matter within our universe. The residual matter which remains after the creation of a solar system is totally dependent on the contributing factors which were present during the creation of the solar system. This is true whether you believe that the origin of the universe was an evolutionary event or that a supreme being caused this event to happen. The two main factors which determine what residual matter remains after the creation of a solar system are the amount of electromagnetic energy and the amount of mass present during the solar system's creation. Our solar system has one star, which is our sun, but the majority of solar systems in our Milky Way galaxy are binary and multiple star systems. In fact, many single star systems have stars that are so large that our sun would appear to be a dwarf by comparison. Keeping all this in mind, it should be obvious that a large single star system, binary star system, or multiple star system would have had more of the prerequisite mass and electromagnetic energy present during their creations. This makes it possible for these systems to possess elements which are not native to the Earth. Scientists have long theorized that there are potential combinations of protons and neutrons which should provide stable elements with atomic numbers higher than any which appear in our periodic chart, though none of these heavy elements occur naturally on Earth. 88 of the first 92 elements on the periodic chart occur naturally on Earth. Some heavier elements do occur in trace amounts, but for the most part we synthesize these heavier elements in laboratories. Generally speaking, the stability of these synthesized heavy elements decreases as their atomic number increases, but experiments at the Lab for Heavy Ion Research in Germany have shown that this may only be true up to a certain point, as the half-life for element 109 is longer than that of element 108. The point is that our observations and theories are accurate. The fact is that heavier stable elements with higher atomic numbers, which have more protons, neutrons, and electrons than any Earth elements, do exist. However, up until this point in history, there has been no physical evidence to prove this. But now that proof is here. The most important attribute of these heavier stable elements is that the gravity A wave is so abundant that it actually extends past the perimeter of the atom. These heavier stable elements literally have their own gravity A field around them, in addition to the gravity B field that is native to all elements. No naturally occurring atoms on Earth have enough protons and neutrons for the cumulative gravity A wave to extend past the perimeter of the atom so you can access it. Even though the distance that the gravity A wave extends is infinitesimal, it is accessible, and it has amplitude, wavelength, and frequency just like any other wave in the electromagnetic spectrum. Once you can access the gravity A wave, you can amplify it just like we amplify any other electromagnetic wave. To demonstrate how a wave is amplified, we can use this oscilloscope, and as you can see, it graphically depicts the tone you hear as a wave. As we amplify the tone, you can see that the size or the amplitude of the wave increases, giving us a more powerful version of the same identical wave, and thus the tone sounds louder. In like manner, the gravity A wave is amplified and then focused on the desired destination to cause the space-time distortion required for space travel. This amplified gravity A wave is so powerful that the only naturally occurring source of gravity that could cause space-time to distort this much would be a black hole. To complete our 3 science lessons, the last question is, what is the power source for this type of travel? Well, for those of you with limited knowledge about power sources, I'm sure you can probably imagine the enormous amount of power required to cause a space-time distortion for this type of travel. After all, we're amplifying a wave that barely extends past the perimeter of an atom until it's large enough to distort vast amounts of space-time. For those of you with extensive knowledge about power sources, I'm sure it's probably even more puzzling as to how it's possible to have a compact, lightweight, onboard power source that can provide this much power. For everyone to understand that, I need to further explain a couple of things we briefly touched upon in the last question. If you remember, I said that for the most part, we synthesize or create heavier elements in accelerators, and their stability decreases as their atomic number increases. So what does this all mean? Well, we synthesize these heavier, unstable elements by using more stable elements as targets in a particle accelerator. We then bombard the target element with various atomic and subatomic particles. At this point, transmutation occurs, making the target element a different, heavier element. This element now has a higher atomic number, as the atomic number simply indicates the number of protons in the nucleus of the atom. So this is what I mean when I say their atomic number increases. What does their stability decreases mean? The length of time which an element exists before it decays determines its stability. Atoms of some elements decay faster than atoms of other elements, so the faster an element decays, the more unstable that element is considered to be. When an atom decays, it releases or radiates subatomic particles and energy, which is the radiation that a Geiger counter detects. As you can see, this Geiger counter is detecting the radiation from this uranium, which literally means that the Geiger counter is sensing the subatomic particles which are being released or radiated as the uranium decays. Those elements in which nuclear radiation can be consistently detected are radioactive elements. These heavy elements, which we synthesize in particle accelerators, are of the radioactive variety, and they decay very rapidly. Since we're only able to make a few atoms of these elements, and because they decay so rapidly, we're not able to observe much about them. This is what I mean when I say their stability decreases. However, there are elements with higher atomic numbers which are stable, even though they don't occur naturally on Earth, and we can synthesize them in particle accelerators. These are the elements in the 114, 115 range which don't appear on a periodic chart. Beyond element 115, the elements become unstable again, and in fact, element 116 decays in fractions of a second. This finally brings us to the power source. The power source is a reactor which uses this element 115 as its fuel. In this reactor, element 115 is used as a target and is bombarded with protons in a small particle accelerator. When a proton plugs into the nucleus of an atom of 115, it increases its atomic number and becomes an atom of element 116, which, remember, decays instantly. What element 116 releases as it decays, or what it radiates, is antimatter. What is antimatter? Antimatter is the exact counterpart of matter, which has a charge and a spin that is in the opposite of all matter. When combined with any matter in our universe, antimatter reacts and completely converts to energy. And remember, the rapid conversion of matter to energy is what we generally call an explosion. To demonstrate the explosive power of antimatter, let's pick a random area where an atomic bomb might explode. Oh, let's say Iraq. And for demonstration purposes, let's say an atomic bomb would explode, for instance, in, Baghdad. Well, if one of our older atomic bombs exploded in Baghdad, the area of total devastation, which is indicated by the red dot on the map, would be approximately 2 miles. This would be caused by a fission reaction in which less than 1% of the nuclear material is converted to energy. Most of you are familiar with the bombs that were dropped on Japan in World War II. This is the same bomb that was dropped on Nagasaki August 9, 1945. About this same time, Dr. Edward Teller, who's known as the father of the hydrogen bomb, figured out that a nuclear fusion bomb was possible. Fusion would release even more energy and cause an even bigger explosion from the same amount of nuclear material. Much to Dr. Teller's dismay, the Japanese surrendered, we never dropped the hydrogen bomb, and Dr. Teller's been in a bad mood ever since. But if a hydrogen bomb containing the same amount of nuclear material as the Nagasaki bomb were to explode in Baghdad, the area of total devastation would be approximately 20 miles. This would be caused by a nuclear fusion reaction, which again, less than 1% of the nuclear material actually converts to energy or explodes. The other 99% of the nuclear material on this type of bomb is dispersed, but is not involved in the actual nuclear fusion reaction. Now, if a bomb was made with the same amount of nuclear material as the Nagasaki bomb, and that material was antimatter, when that bomb exploded in Baghdad, the area of total devastation would include parts of Africa, Europe, and Asia, with the exact area of total devastation being very difficult to calculate.
People always back something they call progress without giving it a proper definition. I think technical innovation is not progress by a long way. Technical innovation can only be progressive when it is combined with a step in the direction of humanity. And it's just that I miss. Nuclear power stations are not progress. Because of this monstrous gigantomania in the buildings and the walled-up concrete areas and the risks, you are here playing with a fire that can't be put out. And the risks are extremely inhuman. And so these gigantic buildings are put up, and especially the military-industrial building complexes, which in the end all lead to the scars of this pseudo-progress practically destroying the natural foundations of human life. And so that the whole of society becomes, in effect, a society of chaotic beings that will lead to global suicide.
There are loads of papers by aeronautics experts, astronautics experts, engineers, showing that trips to nearby stars, our local neighborhood again, within less than 50 light years, are feasible with round-trip times shorter than the average person's lifespan, and without violating or even amending any of our most sacred laws of physics, and using staged fission or fusion propulsion systems, two different nuclear techniques, on both of which I have worked. I said staged again, you notice. Now, some people might think, uh-oh, here comes the science fiction. Got to have science fiction and flying saucers, right? Wrong. There really were nuclear rocket programs. I've worked on both fission and fusion. The NRX-A6 nuclear rocket reactor propulsion system, reactor's only about this big, had a power level of 1,100 megawatts, half the power of Grand Coulee Dam. I worked for Westinghouse on that one. That was preceded, incidentally, just to surprise you a little more, aircraft nuclear propulsion systems in the late 50s. We successfully operated jet engines on nuclear power. Nuclear ramjets in the mid-60s successfully operated nuclear power on the ground. Now, the fission program was the largest, and we had a whole bunch of different systems that we tested. Here's the Phoebus 2B. Los Alamos built these, a whole series of them. Very similar to the NRX-A6, a little larger, maybe this big. The most powerful one had a power level of 4,400 megawatts. That's twice the power of the old Grand Coulee Dam, this big. Now, this isn't Walt Disney now in a science fiction movie. This is reality. That ran, and these pictures were taken from a long distance away. You don't want to be close to one of these things when they're operating. That's nuclear fission. Yes, it's the same energy conversion process that's used in nuclear-powered submarines, aircraft carriers, cruisers. There's over 300 nuclear-powered ships out there. They won't take you into space. But really, I'm much more excited about nuclear fusion. That may seem like a strange word to you. To realize nuclear fusion is the most important source of energy in all our lives. The sun up there is not a mass of burning gas, no oilmen up there. The sun is a fusion factory. That's the process that produces the energy. Now, it's true that indeed H-bombs involve fusion as well. That's controlled fusion, but for a very short period of time. Anyway, back in the early 60s, I worked on nuclear fusion propulsion systems. Government-sponsored contract. We didn't test hardware like the fission rockets. But give the program, $60 billion in 20 years, you'd have man-rated, very exciting, deep space fusion propulsion systems. What's the big deal about fusion? Well, there are two big deals. One is if you use the right stuff in the right way, you can kick particles out the back end of a fusion rocket, only in space now, that have 10 million times as much energy per particle as they can get in one of these chemical rockets. On a miles per gallon basis, surely fusion is the way to go. In addition, the stuff you use to kick out the back end, isotopes of hydrogen and helium, which just happen to be the two lightest and most abundant substances in the universe. Wherever you go, the gas stations may be closed, but you're going to find hydrogen and helium. So we Earthlings already know how to get to the stars. It's a political choice. Do we want to spend the money? I'm not saying we should. But we don't need new laws of physics, just one heck of a lot of good engineering, such as went into this, and courage.
It was outside of this hangar that I saw the sport model tested. Now, when the disk travels near another source of gravity, such as a planet or moon, it doesn't use the same mode of travel that we learned about in our science lessons. When a disk is near another source of gravity, like Earth, the gravity A wave, which propagates outward from the disk, is phase shifted into the gravity B wave, which propagates outward from the Earth, and this creates lift. The gravity amplifiers of the disk can be focused independently, and they are pulsed and do not stay on continuously. Just as the Earth holds all matter down, they produce that same field, but out of phase, and it repels itself. The effects that can cause the way in which everything operates is by all intents and purposes, magic. I mean, it is so far beyond our level of technology.
So progress comes from doing things differently. That also applies when you move over to the other big objection to space travel, deep space travel, and coming here and then making right-angle turns. You'd be crushed to death against the wall, some noisy negativists say. They can't possibly make right-angle turns like that. There's a book, Physics for People Who Don't Think They'd Like Physics, and I don't like the book, which says when you get to 9 Gs, you die. Nonsense. NASA here has learned an awful lot about what kind of accelerations people can stand. They've done tests on centrifuges, rev them up. There's talk about courage, physical courage. Now, 1g is the acceleration of gravity here at the surface of the Earth. That's a change in speed of 21 miles per hour per second. So 1g, in other words, say you're in a very hot car. In 10 seconds at 1g, you could get to 210 miles an hour. That's a pretty hot car. Okay, how much can people stand? Well, it depends on a lot of things. One of the things is the direction of the force on the body. You'll notice that when any of the astronauts go up, they're always on their back. Not like in an elevator. They're not standing up and the rocket goes up this way, but the force is back to front. Why is that? That's because they can stand a lot more acceleration back to front than foot to head. Well, how much can they stand? A trained pilot, this is measured data now, a trained pilot can handle 14 Gs for 2 minutes and perform a tracking task while being accelerated. Now, what does that mean? 14 Gs is an acceleration of just about 300 miles per hour per second. So if you were starting from rest and being kicked at 14 Gs, and it would certainly feel like it, at the end of 1 second, you're going 300 miles an hour. At the end of 10 seconds, you're going 3,000 miles an hour. And at the end of those 2 minutes, you're going 36,000 miles an hour, and you're long since out of sight and off the Earth. That's measured data, not theoretical, hypothetical, I wish we could, but we can't, so we won't kind of data. Now, in actuality, we can stand higher G loadings than that. The shorter the duration, the more the G loadings you can stand. For example, this is test data. You can stand 30 Gs for 1 second. What does that mean? That's 0 to 600 miles an hour in 1 second.
It came up above the same mountain. It moved around. It did a step move. It actually went up in the air like this and hovered, then dropped way down. Then it just floated around and cruised around, and then it started coming up the mountain range.
Now, when people report flying saucers, the time during which you go around the corner is very, very short. As a matter of fact, it appears that you could stand any acceleration as long as the duration is sufficiently short. I call it the hot potato syndrome. You're baking potatoes in the oven. It's time to take them off, out of the oven, put them on the table. You grab the potato. Do you get burned or not? It depends on how long you hold on to the potato. Obviously, if you stay below some very short time, you're not going to get burned. When you go past that time, you're going to be hurt.
Through the telescope, we had seen it was an elliptically shaped light. You know, that's about, because you can only get so close, even with a telescope, to a secure facility. Anyway, it came by up by us very rapidly. It glowed and glowed brighter like a sun, and we almost got the feeling it was going to explode. It glowed so bright, and we backed up behind the car. Then it went down. It glowed back up a little bit, and very softly glided back over back where the mountains where it came up, hovered for a while, and then just sat down, just like you see in the movies.
The beings are 3 to 4 feet tall and weigh 25 to 50 pounds. They have grayish skin and large heads with almond-shaped wraparound eyes. They have very slight nose, mouth, and ear positions and are hairless. Any dates in the information regarding these beings were written in a 6-digit number which began with 1623. Since I had no idea what the 6-digit number was for the present year, I had no way of calculating when these beings arrived, or at least arrived this time. These beings said that they had been visiting Earth for a long time and presented photographic evidence which they contended was over 10,000 years old. There was an exchange of hardware and information in Central Nevada until 1979, at which time there was a conflict which brought the program to an abrupt halt. The beings left, but were to return at a 1623 date, and I don't know what that date is. With the remaining hardware and information, the U.S. government started the back engineering program. In May of 1987, some scientists took an antimatter reactor to an underground blast facility on the Nevada test site to perform an experiment. Unfortunately for them, their experiment required them to cut the reactor open, which resulted in their deaths. This explosion was explained to others at the test site as a previously unannounced low-yield underground nuke test. I was hired in December of 1988 to replace one of these men. These beings conveyed information about the capability of affecting the human brain to anesthetize the human body. This is done without any physical contact from a remote source. For this anesthesia to be accomplished, the brain has to be in a relaxed state similar to that required for hypnosis. If the brain is subject to any external stimulation like stimulant drugs or loud music, this manipulation of the nervous system is ineffective. These beings said that man was the product of externally corrected evolution. They said that man, as a species, had been genetically altered 65 times. They referred to humans as containers, yet I don't know what we're containers of. As I'm sure you now know, it was impossible for me to corroborate the information in the second section. And obviously, if this information is true, the ramifications are far-reaching, and you don't have to be a nuclear physicist to figure that out. So before I bring this to an end, there are a couple of questions I should address for you. The first one is, how did I get into this program? While working at Los Alamos National Lab in 1982, the local newspaper did a front-page story on a jet car I had built. Coincidentally, Dr. Teller was giving a speech in Los Alamos that same day. We met and had a short chat about the jet car, and I later listened to his speech. I never met Dr. Teller again, but in 1988, when I decided to re-enter the scientific community, I sent him a resume and inquired about a job. Dr. Teller responded by telephone and told me that he was no longer active, but just functioned in a consultant capacity. He gave me the name of a contact to call in Las Vegas. I made that call, and things progressed from there until I got into the program. I never got a chance to ask Dr. Teller if he remembered me from Los Alamos, so I don't know if that was a factor or not.
If you use nuclear fuel, and not that possible, nuclear fuel is feasible. But whether these very great velocities are feasible, which are interesting if you ever want to get there and start, that is an important question. And that's about all I can say. All I have time to say. And what specifically the fuel will be, I think it might be fission, more probably fusion. And it won't come soon.
Is there any other nuclear reaction besides fission and fusion that you know of?
No.
Is there anything such?
Look, please, you try to explore the things about which I only will have to tell you it is not interesting, it's a waste of time.
Above plutonium or uranium?
It is, in my opinion, not interesting. I don't intend to answer it. If you ask me that question on camera, I will shut up. I will sit silent. You're not going to get an answer out of me on that.
Okay. And if I ask you on camera if you know Bob Lazar, can you just say no?
I will sit silently.
The propulsion system of the Star Trek consists of two major elements. One is the energy source to provide energy, which is the antimatter system. That makes sense. That could be done. But the propulsion itself, to push the ship, it's called a warp drive, and that has to do with changing space itself and flying faster than the speed of light. We know what antimatter is, and that when you have antimatter and real matter and it comes together, you get a tremendous explosion. You get tremendous energy. E equal mc square, as Einstein said. And so this is the most powerful reaction you get in the universe. Therefore, the Starship Enterprise uses it.
The message from the alien visitors is becoming clear. The human race is producing more problems than it is solving. A change of direction is necessary to guarantee a safe transition into the future. All of creation is light, the key to the universe. The whole of existence throughout the planetary systems, the stars, the depths of interstellar space are all made up of visible and invisible waves of light. To the seen and unseen, to all energy, substance, liquids, gases, and all life, the release of the microatoms of light from oxygen is the source of all life. The electromagnetic waveform, or light. It forms the building blocks of the cosmos in which we have our being, as microatoms of light in greater unities are equal to atoms. Mind forces, spiritual strength, soul attainment, and thoughts are all made up of different speeds in the wavelength of light, or microatoms. Electricity is microatoms of light, while sound and color occur when the microatoms have different speeds. And when microatoms are stopped, they create heat. Light is an intelligent energy which can be thought into existence and substance. The pattern of microatoms of light changes with changing thoughts, when one achieves the formula for the harmonic vibration of light. The key to all life and the universe lies in harmonic interaction of light. The mathematical formula for all transportation lies in the vibratory frequencies of light harmonic, with anti-gravity waves and time waves, which are simply the frequency rate between each pulse of the spiral of light. By controlling this frequency rate, the flow of time can be varied, and one simply moves within one's environment, within the protection of the spaceship, instantaneously from one planet to another, or one solar system to another, where time, as a geometric, is controlled or eliminated. Why is such technology available only to the few and not to the whole of mankind? Have we the right to know? Are we ready for it yet? Or is the race for technological advantage more important?
Why keep a secret about probably one of the most important events in history, that there's been contact from an alien civilization? It's a significant event in history, more significant than anything.
With the tremendous distances involved, travel to the stars would seem impossible. But with man's endeavor and resourcefulness, these problems will be overcome as they always have been in the past. Scientific estimates tell us that there will be a breakthrough in space travel in the near future. When the boundaries of distance break down, the Earth will become our home, the universe our world. If NASA has its way, many of the next generation will be residents of Mars, and the move towards this has already begun with the development of a space station. This was the essential first step towards making man a citizen of the universe. Out of that understanding, echoes and newly realized desires arise to provide oneself with a new quality of life. The awareness of oneself and the place one occupies in the universal law of exchange is the framework of cosmic expectation, the unselfish expression of love and creation. The cosmos is filled with all the energy we need. It's like walking along the beach picking up diamonds.
So you can raise any of those objections you wish, but please don't reach a conclusion until you've studied the evidence.